Hi guys, welcome back to my channel Pirai Academy. In the series of data structure playlist, today we are going to see about binary tree implementation. In previous video, we have already saw about binary tree traversing methods, okay, like DFS and BFS. Now we are going to additionally implement some other ADTs like insertion, deletion, searching, and also the traversing method will be useful. Okay, if you haven't saw my traversing video, just go and watch it. I'll be giving the link in the description. And also further you want to know about recursion, stack, and also queues. If you also don't know about these three things, I'll be also giving these three links in the description. Just go and watch those introduction video. Fine. Now let's get started. So see here are some of the operations, and meanwhile I will be constructing them as a tree. Okay, fine. Just listen to me. First, we are going to implement a complete binary tree. Okay, we are not going to implement any other binary tree. We are just going to be implementing complete binary tree. So this will be much easier to understand. That's the reason why I am taking the complete binary tree. And also if you can understand this implementation, we can next in upcoming video you can understand the heap implementation easily. Okay, that we will be using the complete binary tree only. Okay, fine. Like not exactly complete binary tree, but our imagination, the assumption will be like complete binary tree. Okay, fine. Now you want to know about what are all those three attributes that will be the node of the binary tree. Okay, there will be three attributes. One is left address, right address, and middle will be node, roots value, that's node's value. Okay, so this is going to be the one node of the binary tree. Now let's get started. So first of all, it is what? Insert of 2. So this is going to be the root. Whatever element that is going to be inserted first will be the root. Okay, now I'll be inserting it. So how I'm going to do it? I'll be creating a new node whose left address going to be null initially, whose value going to be 2, and its right address also going to be null. And this is going to be the root. Okay, fine. Now second one, insert 10. Then I will be creating a new node called 10. Okay, and here it will be null, here 10, again here it will be null. Okay, now take for example this address is 200. Then I will be just going level by level. Again, if you don't know about the traversing technique, it is completely difficult for you to understand this. Okay, that's the reason why just go and watch the traversing technique, then come here. Okay, I will be going level by level like this. Okay, so I'll be just going level by level. First I will be going here, this level. Here the root node, okay, its left address is what? It is null, which means we can insert that, right? So instead of null, I'll be replacing this as 200, which means this will be pointing towards this. Can you understand this? Yes, fine. Now next one is insert 29. So I'll be creating a node of value 29 whose left and right are going to be null. Fine. Now take for example its address is 300. Okay, now I'll be again traversing level by level. So at the first level itself, this level 0 itself, the right value is what? Null. So what I'm going to do, first I'll be checking the left value is not null. Now right value, it is null, right? So at this particular point, what I am going to do is I'll be just changing this into 300, the newly created node address, so that a link will be like this. Can I understand this? Yes. Now insert 30. So I'll be just creating a new node called 30. Fine. Now I'm going to traverse. So in BFS manner, right? Level by level means it is going to be absolutely BFS manner. So I'll be traversing here. What this nodes left and right are not equal to null. Okay, then go to the next level like this, the level 1. Here also the left value is what? Null. Then I can surely tell what? I'll be making this address to this. So for example, its address is 500 for example. Okay, then I'll be making this null into 500 and I'll be pointing like this. It will be pointing like this. Okay, now what's the next thing? It is insert of 3. Okay, so I'll be creating a new node whose value is 3, whose next right and left value is null. Okay, now again I will be traversing in a level order manner level order manner. So I'll be traversing like this. So here the left and right are not equal to null. Then I'll be coming here. Here also this node's left is not equal to null, but its right is null. Right is null. So here I can insert it, right? So take for example, its address is 600. Then I'll be replacing this into 600. Okay, so that a connection will be like this. Don't worry if you cannot come up with the code while I am dry running in the code, you can understand this. Okay, when I am showing you the code, you can understand what I am doing here. Okay, just come up with the logic alone. Okay, fine. Now the next thing is insert 7, right? Okay, so I will be inserting a node and its value going to be 7, its right child and its left child going to be null. Okay, fine. Now again where to insert it, right? So for example, its address is 1000. Now I'll be just going level by level. So in this level there's only one node and its left and right child are occupied. Now again come this level, here also for this particular node left and right child are occupied because it is not equal to null, but here its left child is null. So here I am going to insert what is the value, 1000, so that a connection will be built like this. Okay, now the next thing is insert of 4. Okay, so just create a new node 4 and its left and right going to be null. Okay, now let's assume its address is 1200. Okay, now I'll be again traversing level by level. In this level there is only one node and its left and right are occupied. Now come to the next level. Here also, here it is left and right are occupied. Here the left is occupied but right is not occupied because it is null, right? So at this particular point I'll be inserting it. So I'll be inserting what, 1200. Just change the right value as 1200 so that a link will be there. Fine, that's it. Now going to the next step, searching. So for searching you can either use in order traversal, post order traversal, pre-order traversal, or you can also use the level order traversal. That's your wish. What you are going to do is, see here the search value is 5, right? Search value is 5. So you will be starting from the root and check all the values which is equal to 5 or not. Okay, if any value is equal to 5, then you will be returning true, else you will be returning false. Can you understand this? Okay, so here you can use any traversal method, in order or post order or pre-order or level order, anything you can use. Okay, so it is easy. I will be directly showing this in the code. Okay, I think I will be implementing a level order traversal, I don't know, but you can also implement using any order traversal. Okay, fine. Now here also for search also it will be like that. Okay, so if I use a level order traversal, then I will be traversing in the first level. Okay, whether this 2 is equal to 7, no, go to the next level. Whether this 10 is equal to this 7, no. Whether this 29 is equal to 7, no, go to the next level. Whether this 30 is equal to 7, no. 3 is equal to 7, no. Whether this 7 is equal to 7, yes. In this case I will be returning true. If it is 5, then 5 is not matched with any of those elements, right? In this case I will be returning false. Can you understand this? So if you know about the traversing technique, then you can able to solve this. Okay, that's the reason why I told you just go and watch the traversing technique first, then come to this video. Okay, fine. Now coming to the next thing. Next thing is delete of 3. So basically insertion and searching is going to be much more easier than the deleting. So delete of 3, right? So I'll be giving you what is the logic behind it, and just understand it. When we are going to implement the code, I will be giving you the dry run. In that time you can understand this clearly. Okay, so now I will be giving you a rough overview. Okay, just see here. First of all, I will be going level by level. So at this level 0, whether this 2 is equal to this 3, no. Again go by level. Whether this 10 is equal to 3, no. Whether this 29 is equal to 3, no. Now go here. Whether this 30 is equal to 3, no. Whether 3 is equal to 3, yes. At this particular point, you will be doing what? Let me put here. You will be doing here what is the element that is going to be deleted is equal to 600. So this is going to be the address that we want to delete. Okay, and then I'll be just checking which element should be shared there. Because see here, for example, let me give you the final output so that you can understand this clearly. 2, 10, 29, here comes 30, here comes 3, here comes 7, here comes 4. So this is how it is, right? Now after deleting it, here comes 4 and this 4 should be disappeared. Okay, so this is how the final tree should look like. Okay, so now to make this, first I have taken the element that should be deleted first. Okay, so that's over. Now the second step I want to do is I want to go to the last element. and to its parent, right? So while traversing itself, I will be checking what is the last element and what is the last element's parent. Can you understand this? For example, here the last element is going to be 1200. Meanwhile, its parent going to be, the parent of last element is going to be 300. So I will be finding these out, and when I will be showing you the code, I'll be telling you how we are going to find this 600, this 1200, this 300, these addresses. How we are going to find these addresses in the code implementation. Now just understand, we have taken these all. Okay, now the next step I'm going to do is I will be just taking the last value, What is the last value? It is 4. I will be taking this 4 and replacing here. Can you understand this? I'll be taking that 4 and replacing here, and in my parent of the last, I'll be deleting the particular address. Which means this 200 will be turned into null, which means this element will be just deleted. Now see here, it follows the complete binary tree. See here, everything are filled from the left to right. And also node to leaf node have its level which is greater than, the level difference is greater than 1. Can you understand this? Now it follows the complete binary tree property. That's it. Can you understand the deletion method? Okay. My kind request is, you don't want to understand these 3 things computation. Just understand somehow we have computed these 3 things and we have done this. That's it. Okay. Now for deletion of 4, you can do this deletion of 4, right? Try by yourself. For this deletion of 5, when I am going level by level, I cannot find 5. So I will be just outputting, hey, there is no element to delete. That's it. Okay. For deletion of 4, just try by yourself with the use of this tree. So let us see the code implementation of the binary tree. Now I am going to implement this using the C++. If you want Java or Python code, you can go and search in my description. And also, if you are thorough with the pre-order, in-order, post-order and level order traversal, mainly the level order traversal, then only you can understand this code. Okay, in drawing explanation also, I didn't gone with the entire level order traversal. I just told you we are going by level. That's it. Because if you can understand the traversal, then only you can understand the implementation of the binary tree. Okay, fine. Let's get started. First of all, I want to create a node, right? For that node, I have 3 attributes. One is value, next one is left address, next one is right address. So I have created them, and I'll be initializing them in the constructor. Meanwhile, the left and right will be pointing towards the null pointer. Okay. Here you can also use the structures, because it is C++. In C++, you also have a structured data structure. Sorry, data type, right? Here I am using a class data type. Fine. Now here this class binary tree will be the implementation. Will be having the implementation of the binary tree. Okay. Fine. So see here has a data member. So node star root. Okay. So this is going to be the only data member we have, and this data member will be holding the root. Okay, root address. Fine. Now see here in the constructor, I'll be just creating, I'll be getting the value as a parameter, and I'll be creating a new node and assigning that new node towards the root. Can you understand this? So this is done in a constructor. We're creating an object for the binary tree itself. Okay. Now here comes another important entity called insert. So here we are going to do a insertion operation. So here we will be getting a parameter as value. Okay, now I'll be creating a new node by using that value we have got, okay, from the parameter. Now if the root is equal to null pointer, then what should I do? Then root is equal to new node and return it. You may ask, hey, already we have done the root here, we have initialized the root here, then how come the root comes to the null pointer? You forgot about the deletion. In deletion, if we have only root, for example, root value is for 10, okay, and I'll be just doing a deletion of 10, then what happens? The root will be deleted and root will be pointing to what? Null pointer. In that particular scenario, this will be helpful. So this is how we want to encounter the edge case. Okay. Also, you may also come up with some other edge case in my code. Okay. If you come up with some other edge case, just comment below. I'll be rectifying them. Okay. Fine. Now, I am just initializing the queue first, and inside the queue I'll be pushing the root value, root address. Okay, so now inside the queue there will be only one element called root. Okay, now while my queue is not empty, what should I do? First of all, I will be just getting the front of the queue and popping the queue out. Okay, because in C++, if I do queue.pop, then that value will be not returned. That's the reason I am doing a queue.front and then popping. Fine. Now, if the node left is equal to null pointer, then I want to just insert that new node in the nodes left. Can you understand this? I am going by level. In each and every level, if I encounter any null pointer in my left side, then I will be just making the new node to be pointed to the nodes left. Okay, then else if the node right is equal to null pointer, then node right will be new node and I'll be returning from that. Can you understand this? Then at last I'll be pushing the nodes left and nodes right. Can you understand this? So here also you can do like if nodes left is not equal to null pointer, then you will be pushing it. If nodes right is not equal to null pointer, then you can push it. So here I will be adding one case. So if node left is not equal to null pointer, then I will be doing this. Here also, if node right is not equal to null pointer, so you can do this, but in our code, if node left is null pointer, then it will not go to this control flow. Okay, if for example this condition is satisfied, then it will be returning from here. The control flow will not reach these lines. That's the reason why I didn't add them. But if you want to add them, you can add them. Okay, like if you put these two lines, you may or you may not. Okay, fine. For me, I'll be just putting them. Okay, fine. Now see here comes the searching operation. In searching, I'll be returning a boolean value. Okay, now here I'll be just getting the parameter as root and also value. Here I'm doing a traversing. Here I am doing DFS traversal. You can also do a BFS traversal using a queue data structure. My kind request is, here I have taught you the DFS traversal. Then by yourself, you should do by using a BFS traversal, by using a queue. Okay, so see here. So if you cannot understand the recursion, then this is going to be much more difficult for you. First go and learn the recursion, then continue this. Okay, fine. Now if that is not root, which means root is equal to null pointer, then I want to return false. Okay, so this is going to be the first base condition. Then next base condition is, if the root value is equal to the value that they have given to find, then I'll be returning true. Else what should I do? Return search of roots left comma value, or search right roots right comma value, which means hey, go to the left subtree and search for this value. Hey, go to the right subtree and search for this value. When my current node's value is not equal to value that they have given in the parameter. Can you understand this? So if you cannot understand the recursion, then this is going to be tougher for you. Okay, fine. Now so you already know about the in order, pre-order, post order and level order traversal. So I left over. I am not going to explain these things. Okay, now let's get started with the delete node. So delete node of int value. So they will be giving you a value and we want to delete that particular node. Okay, fine. So here also, if there is not root, which means root is equal to the null pointer, then there what should I do? Tree is empty. So that should be my message. Okay, fine. Now queue. So I am initializing a queue. Okay. Now I am pushing the root into the queue. Okay. Now I am taking three pointers. You know these 3 pointers, right? Node to be deleted, last node, and parent of the last node. So I already thought in the drawing explanation, right? Okay. Now listen this carefully, because deletion is going to be much tougher than you think. Okay. Just listen this. Now, while my queue is not empty, then what should I do? I will be taking the front of the queue and taking that value and storing in node. Now I will be just popping the front value. Okay. Now I am doing a level order traversal. If node value is equal to val, then what will you do? Node to be deleted is equal to the particular node. Now you got what should be stored in the node to deleted, right? I am going level by level. While going by level, I will be checking whether the particular value is equal to the value. Then I will be storing that into the node to delete. Okay, so we have found out the node to delete successfully. Fine. Now, if node left, then parent of last equal to node. Okay, and queue that push of node left, which means in as usual in the level order traversal, we will be checking whether the node have left. Then we will be inserting the left value into the queue. Meanwhile, whenever we are inserting like that, I will be just updating my parent of last node, because the parent of the last node will have like the last address in either in its left side or in its right side. Can I understand this? See here in drawing explanation here. Let me change the color. So this is going to be the parent of the last node and its right child is the last node, right? So we want this address. That's the reason why I am going to update whenever I am going to traverse. Like when I am traversing like this 0th level, first I will be taking this 200 as my parent of last. Then I will be taking this 300. Then I will be taking this 500. Then I am taking this 600. Then I am taking the 1000. Then I am taking 1200 like that. Can I understand this? Yes. Okay, fine. Now, when we are going here, when we are going to the last level, here it is null, right? So this will be not updated. I forgot to tell that. Here it will be not updated because here it is 1200. When we are before we are deleting this, right? Here it will be 1200, but here it will be null. So these last level addresses will be not updated, so that only our our parent of the last node will be existing as 300. Can I understand this? Okay, now let us continue this. So I can understand this is somewhat difficult to understand, but you can go by twice and rerun by yourself so that you can understand this. Okay, fine. Now if node write, then what should I do? I will be just taking that as my parent of the last, okay, that particular node, and I will be inserting the nodes write into the queue. See here, if you do this first and do this next, then the order will be changed. Then it will be not a complete binary. Okay, always do the left first, then only do the right next. Okay, because you want a complete binary, and also it is a level order traversal. Right. Now at last node is equal to node. That's it. Okay, fine. Now come here. So after finishing this entire loop, now I'll be coming here. If there is not like node to be deleted, which means node to be deleted is equal to null pointer. Here we have already initializing it, right? So if it is equal to the null pointer, then here I'll be telling like here this value is not found. Okay, so this is one of the case. Or another case is if I found it, and also if we have the last node, then what should I do? I'll be just going here and taking the node to delete value and reinitializing it as a last node value. I told you that, right? Instead of 3, I'll be replacing the last node, that 4 there. Like that we have initializing here. Okay, if parent of the last node is there, then what should you do? I want to check whether parent of last right is equal to the last node, or parent of left is equal to the last node. I want to check, and I will be making that as a null pointer. It is simple, right? Okay, now here comes elif. What should I do? I want to check for last node is equal to the root, which means we have only one node, and that one node should be deleted, and that one node is equal to the root. Then what should I do? I will be simply making this root as null pointer. Now you can understand why I am putting here some condition here. So this condition is when we have only one element and we are deleting it, then the root will be what? Null pointer. In that case, we want that edge case for the insertion method. Okay, now at last I'll be just printing a message like the value is deleted, like that. Okay, now here comes the main function. In that main function, I'll be just creating an object, and I'll be calling some of its functionality. And see here I'm doing a level traversal, and here I deleting some value and again doing a level traversal to know about whether it is deleted or not, like that. Okay, so you can also do here like a menu driven program. Okay, that's your wish. You can just go and do a menu driven program here in a main function. Okay, so this is the overall code implementation of binary tree. Okay, if you have any doubts in this binary tree, just comment below, or if you found any mistakes, then you can also free to comment below. Okay, fine. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist, because all videos will be helpful once you are going for a competitive programming. And by seeing this tree, okay, by coming up with logics of how to solve the tree questions, then this will be helpful in recursion, backtracking, and also in graph. If you can understand the tree logics, then it will be moreover easy for you to understand the recursion and also the graph. Okay, so please be focused for this tree kind of videos. Okay, thank you.